Okay, on this one, we're gonna join two previous lessons. We've talked about linear inequalities in the last lesson, and we've talked about systems earlier in the chapter. So a system of linear equalities would just simply be two or more linear inequalities in the same problem. So the solution to a system of linear equalities is the set of ordered pairs that satisfy all. So every one of these that we're working are and statements. So it needs to satisfy everything, not just part of it, but everything. So to graph these, pretty easy. We're going to graph and shade each linear equality. The solution is going to be the overlap, the same way with the and statements that we did with our when we were doing like x is greater than 3 and x is less than 5. Same type thing. We're looking for where do these overlap? What satisfies both? So number one, let's go ahead and get started. Graph each individually. So you have y is less than negative 2/3 x minus 1. Y-intercept is negative 1. Slope is negative 2/3. So go down to and over 3, down to over 3. Continue doing that. Since it's or equal to, we're going to connect this with a solid line. And there that is. And we are going to shade, since it's less than, we're going to shade below. Now, let's go ahead and shade. Then your next line, let's change colors. It's very easy to, if you have colored pencils or something like that, it's much easier to see this if you go ahead and change colors. Y equals greater than or equal to 1/2 x minus 8. So y-intercept is negative 8. 1, 2, 3, 4, 5, 6, 7, 8, which is down here. Slope is 1/2, so rise 1, run 2, rise 1, run 2. Continue doing that. It crosses there, and there is going to be our line. I'm just going to draw this one with my free hand. So there is your line, and we've got to shade above, because the greater than or equal to, we're going to shade above that line. So that would be everything here. Now here's what you got to do. Your solution is where these two things overlap. So let me change colors one more time. I shaded above the red line. So above this line, I shaded below this line. Those two things overlap here. So I'm going to shade over here where they overlap, and you can actually then go back if you want to, and you can erase the first two. My solution will be that region. Again, I wanted everything below the blue line, but it also had to be above this line, the red line, so therefore that would be my solution set. So any point here, 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 any of these points in this region would be a solution to this system. Okay, another one. Y is less than or equal to 3/4 x minus 4. Y-intercept is negative 4. The slope is 3/4, so rise 1, 2, 3, 1, 2, 3, run 4. Do it again, 1, 2, 3, 1, 2, 3, 4. Or you can go down 3 and left 1, 2, 3, 4. Let's connect our dots. And we are going to connect our dots with a solid line, remember, because of the or equal to. And since that is less than, there's your line. Since it's less than, we're going to shade everything below it for that part. The second inequality is y is greater than negative 7. Now, if you remember, y equals negative 7 is going to be a horizontal line. So let's go down to 1, 2, 3, 4, 5, 6, 7. There's my horizontal line is where I'm going to draw it. Since it's not or equal to, I'm going to dot it. So let's dot our horizontal line here. And I've got to shade everything above that line. So that could be any of this stuff here. And you're simply looking for where do those two regions overlap. So you got to be above the blue line. You've got to be below the orange line. So then you are in this region right here. And again, just to let you see it better, I'm going to go back and erase these two. So your solution is anything in this region. When you draw these two lines, you always will divide your quadrants into 4 regions here. You're going to divide your graph into 4 regions. And your solution is going to be one of those 4 regions. So again, any point inside of that region is going to be an answer or a solution to that system. Next one, x minus y is greater than 1. That's not in slope intercept. So since I'm going to solve that, we have you can move the x over, or you can use my shortcut. You have negative y. Move the x over by changing it to negative 1x. I'm going to put the 1 so I'll have something to divide by. We're going to divide by this -1. Now, when you divide by -1, remember that you do have to flip your inequality symbol. So you now have y is less than 1x, positive 1, minus 1. So that now has a y-intercept of -1 and a slope of 1. So 1 over 1, continue on and on and on. And this would be your line. And I'm going to go ahead and do it for the whole graph here. And you could actually treat that. We need a dotted line, so you can actually leave your dots, or you can go back and you can kind of dot it as you go here. And we've got to shade. Since it's a less than, we need to shade below that line. So I'm going to shade down here. And then we graph my other line. Let's change colors. Let's move our x over. We now have 4y is greater than, change it to -1x as you move it, plus 20. Divide everything by 4. And you now have y is greater than, don't flip your symbol, -1/4 x plus 5. So we're going to cross at 1, 2, 3, 4, y-intercept of 5. Slope is -1/4. So down 1 over 1, 2, 3, 4. Down 1 over 1, 2, 3, 4. Or up 1 and left 1, 2, 3, 4. Since it's not or equal to, we're going to dot this line. So it'd be a dashed line or dotted line. It doesn't matter which one you use. So there's your line. We're going to shade, since it's greater than, we're going to shade everything above this line. So we shaded everything, and I need to extend this on. We shaded everything below the red line. We shaded everything above the blue line. So my intersecting region would be this region over here. That's going to be the solution. Number 4. To get this in slope-intercept form, let's move our 7x over. That becomes minus 7x. Leave the 18, divide everything by 3. And hopefully you're getting really good at getting these in slope-intercept form. We've done several of them now. We're going to have a y-intercept of 6. 1, 2, 3, 4, 5, 6. So we're going to go down, and that should be or equal to. I lost my or equal to symbol. We're going to go down 7 over 3. So down 7 over 1, 2, 3. You might be able to do it again. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3. There's my line. Or excuse me, there's my points. Now let's draw a line through it. And there is my line. And we are going to shade, since it's less than or equal to, we're going to shade everything below it. So that'd be all of this stuff. Again, if you can't figure out which way to shade, go to any point and then ask yourself which side would be below and which side would be above. You're going to shade below, so that's the reason I shaded to the side I did. The other one, well, let's leave -3y. Let's move our 2x over, and it becomes -2x. Divide everything by -3. Since you are dividing by a negative, make sure you flip your symbol. Greater than or equal to. Negative divided by negative is a positive. Positive divided by negative is a negative. So 2/3 x minus 3. Minus 3 will be your y-intercept. Rise 2, run 3, and continue doing it. Or go down 2 and left 3 a couple of times. This will be also a solid line. So let's draw our line. And there is your line, and you're going to shade everything above that line. So we're shading everything to this side of that line. And again, you simply ask yourself, where's the overlap? And it's being overlapped in this region. So anything in this region will be a solution. And again, you can, if you would like to, you can get rid of your other colors. So your answer is all of this stuff right here, all of those points. Number 5. Move your x term. You have 2y is less than -1x minus 6. Divide everything by 2. And you have y is less than -1/2 x minus 3. There's your first line. Y-intercept is -3. Slope is -1/2. Make sure it goes downhill. There is your line. Or you can go up 1 and over 2. Since this is not or equal to, this would be a dotted line or a dashed line. We're going to shade, since it's less than, we're shading everything below this line. So here's another possible way of doing this. Okay, a lot of times I'll just draw arrows instead of doing the real big bulky shading. If you don't have two different colors, you might want to just do some arrows saying, okay, we need to shade below this line. Y below, go to any point on the line and ask yourself which way is below. The second equation, let's move our 4x over. So we have now negative 2y is less than positive 4x minus 10. Divide everything by negative 2 and flip your symbol. Y is greater than negative 2x plus 5. So we got to go up to 1, 2, 3, 4, 5 is our y-intercept. Our slope is negative 2. So it would look something like this. And it is also just greater than, so we're not going to need we're going to need a dotted or a dashed line again for this one. And we've got to shade above this line. So we're going to shade this way, everything above it. So we've got to figure out, and if you look at my arrows here, we've got to figure out what's above the blue line, which is all the stuff up here, but it also has to be below the red line. Where is that overlapping set? Well, this is below the red, but it's not above blue. This is neither. This is above blue, but it's not below red. So your solution would be this fourth set of points that are all down here. Number 6. Let's move our 4x, and you have now negative 5y is greater than negative 4x minus 5. Divide everything by negative 5. Since you divided by a negative, don't forget to flip your symbol. That's y is less than negative divided by negative, and also a negative divided by negative is positive 1. So positive 1 is your y-intercept, down 4, or excuse me, up 4 and over 5. So 1, 2, 3, 4, 1, 2, 3, 4, 5 to get some more points on this line. 1, 2, 3, 4, 1, 2, 3, 4, 5. Connect your dots. And there's your line. We've got to shade everything below. So we're going to shade to this side. So I'm going to do my trick again. I'm going to just draw some arrows saying, okay, we got to shade below that line. Now, x is less than 1 or negative 1. If you remember, x equals a number is going to be a vertical line. So I'm going to come over here to negative 1. And I'm going to draw a vertical line that passes through that negative 1. Okay, now let's figure out where to shade. Smaller than negative 1. Numbers, since it's a vertical line, numbers smaller than negative 1 are going to appear on this side of my vertical line. So now, look at my two lines. Let me change colors again. I've got to shade things below my orange line and to the left of my red line. So go to the 4 regions. 1, 2, 3. There's 4 regions formed here. Region number 1, you ask yourself, is that left of the red line and below the orange line? And yes, it is left of red, but it's not below orange. Region 2 is neither left of red or below the orange. Region 3 is below orange, but it's not left of red. So therefore, region 4 is both. There should be only one region that works. So that would be your 4th region down here. Let's try that again. So that's all your solutions. Okay, on number 7, they're asking you to test some points. Which ones fall in the right region? Now, there's a couple of different ways you could do this. You could graph these, and you could look at the graph of them, and you could see which one of these fall in the right region, or you can just plug them in. Well, what I'm going to do is I'll plug in 2 or 3 of them, then we'll look at the graph and show you how to check it as well with a graph. So let's start with 1, 1. Let's test 1, 1. We will test 9, negative 2, and we will test 3, 4. Let me zoom in here. So 1, 1. We're going to plug in 1 for x and 1 for y. Now, in order to be a part of the solution, it has to satisfy both of these. So plug it into the first one, and it gives you 1 minus 6 is greater than negative 48. That's negative 5 is greater than negative 48, and that is true. So it works for the first one, but it has to work for both. So now let's try it in the second one. 2 times 1 is 2, plus 3 times 1 is 3. 2 plus 3 is less than 9. That is 5 is less than 9. That also checks out. So therefore, 1, 1 does satisfy both of them. Let's try the point 9, negative 2. Plug in 9 into your first one for x. It has 9. Plug in negative 2 for y. You have negative 6 times negative 2, which would be a positive 12, is greater than negative 48. 9 and 12 is 21, is greater than negative 48, and that is true. Now let's try our point in our second one. And again, in order to be a solution, it must work for both. So let's plug in 9 for x and negative 2 for y. That would be, I'm going to write it up here, 18. Positive 3 times negative 2 is a negative 6. 18 minus 6 is less than 9. That'd be a 12 is less than 9, and that is not true. 12 is bigger than 9. So even though it satisfied the first, it did not satisfy the second one. So 9 negative 2 does not work. 3, 4. 3 for x gives you 3. Negative 4 times 6 for y would be a negative 24, is greater than negative 48. That'd be negative 21 is greater than negative 48, which checks out. Now let's try the point to the second one. 2 times 3 is 6, plus 3 times 4 is 12. Is that less than 9? 18 is less than 9 is not true. So even though it worked for one, it did not work for the other one. So it's not a solution. Okay, so let's go over, again, here is our problem. Let's go over to Desmos and look. And I've actually graphed, and this is the great thing about Desmos, or another great thing about Desmos. Here's where I graphed the two inequalities, and you can do inequalities on this. Notice I did the greater than and less than. X minus 6y is greater than negative 48, our first one, and 2x plus 3y is less than 9. And then what I did is I took, and you didn't have to do this part, but I plotted every one of these points. And let me get this off the screen now. Look what you've got. We have to shade below this line, so that'd be down here in one of these. And then I've got to shade below this red line, which would be down here. So my overlap, they've even colored it in. My overlap is all the stuff in this region right here. So which of these points satisfies both of them would be this point here at negative 8, negative 3, 4, negative 7, and 1, 1. And we saw that 1, 1 did, but our other two solutions to this would be negative 8, negative 3, and 4, negative 7. That quick. Negative 8, negative 3, 4, negative 7. Now what about negative 2, 6? You can find negative 2, 6 right here and see that, yes, it is below the red line, but it's not also below the blue line, so it doesn't satisfy both. And thus, it would not be a solution. Okay, number 8. It says to raise money to attend Boy Scouts, Alex is selling popcorn. Small bags sell for $4, large bags sell for $6. He needs to earn $300 to attend camp. He will also earn a badge if he sells at least 60 bags in combination. So we've got a few different, let me erase that. Got a few different parameters, a few different equations here that we can write. Let's see. Small bags sell for $4. So that means let's let our small bags be X, our large bags be Y. So he's going to make $4 for every X he sells, plus he's going to make $6 for every large he sells. So there's how much money he's going to make. He needs to make at least 300. So he can make more. So the amount of money that he makes needs to be more or equal to 300. Also, he gets a badge if he sells at least 60 bags. So the amount he sells, which will be X plus Y, that's the amount of X's he sells plus the amount of Y's he sells, needs to be greater than or equal to 60. Now, there's a couple more parameters here that you don't see, and it deals with domain and range. So let's talk about that. And I don't know if they want you to throw this in, but I do. Small bags of popcorn are X. Can you sell negative bags of popcorn? Could X be negative 3? Could X be negative 4? No. X has to be greater than or equal to 0. Now, could you sell 0 bags? Sure. What about your Y's? Y's are the large bags of popcorns. Y has to be greater than or equal to 0 as well. A lot of times in real life situations, your X and your Y's can't be negative values, so you can throw in these other two parameters, and that's going to limit you to where you're going to be graphing, and we'll look more at that in just a second. So each of these, let's go ahead and get them ready to graph so that we know what kind of x-intercepts and y-intercepts and all that we're going to have. So the first one, let's move our 4x over, see if we can graph this in slope-intercept form here. Gives you 6y is greater than or equal to negative 4x plus 300. Divide everything by 6, and that gives me y is greater than or equal to negative 2/3 x plus 50. Let's go ahead and solve the second one as well and see what these graphs are going to look like. On the second one, all I've got to do is move that x over. You get y is greater than or equal to negative x plus 60. So we need to graph these two things first, and then we'll talk about what the graphs of those last two look like. So the first one, I need a 50 and I need a 60 for a y-intercept. So let's see. There's 15 lines here. I think I can let each line count 5, and it would very easily fit 5, 10, 15, 20, 25, 30, and so on and so forth. And in order for your scale to work to where you can do your slope without doing a little bit of extra work, let's let both our x scale and our y scale be the same. So my first graph has a y-intercept of 50. It has a slope of negative 2/3, so down 2 over 3, down 2 over 3. Now let's talk a little bit more about why you can do that, why your scale is important here. When you go down 2 and over 3, you're technically going down 10 and over 15, which is legal. Going down 10 and over 15, if you reduce that, is the same thing as doing down 2 and over 3. So that's the reason it's so important to keep your scale the same. Let's go ahead and connect our dots and think about where we're going to shade. There's my line, and since it is greater than, I've got to sell more. I've got to be above that line, so we're going to shade above this line. My second line, let's do it in a different color. Negative x plus 60. So I have a y-intercept of 60. My slope is negative 1, so I'm going down 1 and over 1, which is going to look like this. It's going to cross there. And it looks like I'm going to have an x-intercept of 60 there. So let's connect those dots. And I also have to shade above that line. So it has to be above the red line and above the blue line. Okay, let's go ahead and talk about those other two parameters. X is greater than or equal to 0. If you were to graph x equals 0, you would on your x-axis go to 0, which is right here, and you would draw a line at x equals 0, which would be that vertical line. So we have to be to the right. These are all the values greater than 0, because if you think a dot over here, that would be an x value of negative 1. So we've got to be to the right of my x equals 0. Y equals 0 is this line. And we've got to be above that. So if you think about it, what that does when it says that x is greater than 0 and y is greater than 0, you know what this is? Pretty much that tells you you've got to be in the first quadrant. You got to be in quadrant 1, because that's where x is positive and y is positive. So now let's see where all of these overlap, and we'll do a different color here. We'll do purple. We've got to be above red. We got to be above blue. So start thinking, what about this point right here? That's above blue, but it's not above red. What about this point? That's above red, not above blue. What about this point? That's above blue and above red. That's to the right of this line, and that's above this line. So the region that we're going to be working with is this region, down into there, all up into here. So any of those points. So use your graph, give two possible combinations of bags of popcorn. So we can zoom in here now, and let's look a little bit closer. So here's a possible combination, or here's a possible combination. Now let's talk about this point though. Is that a possible combination? Because since it's or equal to, not only do we have to be in this region, but we could also, since it's or equal to, since it's a solid line, this is also a possibility. So we could sell 30 x's and 30 y's. That would be one way. So x could be 30, y could be 30. We could do this point, which would be x could be 25 and 40. 25 and 40, that's a possibility. We could be at this point up here, which would be 55 and, let's see, that was 35 on the other side, so 55 and 35. And again, any point that's, now this point does not work because this point is not above or on the red. That would be below the red, so we can't use that one. But however, we could use this point. That would be 15 and 45 would work. So any of those combinations, and you can go back and you can check those. Any of those 4 points should satisfy. Obviously, these because they're both greater than zero. Everything's positive there, but it should settle. It should accommodate that's equation or inequality, and it should accommodate that one as well. Okay, number nine. Number nine says Greg needs to at least $1.60 in stamps to mail a package. He has 28 cents and 4 cent stamps. He can use no more than 24-cent stamps as he only has one book left. So our unknowns here, always identify them. The number of 28-cent stamps we're going to use would be our X. The number of 4-cent stamps we use are going to be our Y. So let's set it up. Let's see. Each 28-cent stamp, okay, there's X of them. We're going to use X. So the amount that would be worth would be 28 times however many you use, plus the 4-cent stamps would be worth 4 times however many you use. Now we got to be careful because if we're going to talk about 28 cents and 4 cents, over here where it says $1.60, if we're going to talk about 28 cents, we're going to have to use 0.28 if we use $1.60 because we're talking about money here, the amount of dollars and the amount of cents. However, if you want to say 28 cents and 4 cents, you can actually, instead of saying $1.60, we can say 160 cents. So be really careful to make that uniform. So the amount he needs is at least. It has to be either greater, because you could put more money on there. I don't know why you would, but you can be greater than or equal to $1.60, which would again be 160 cents. He can also use no more than 24-cent stamps. The 4-cent stamps are Y, so the Y value must be less than or equal to 20. He can't use more than 20. In the same way on the last one that we threw these in, let's do it again. You can't use negative X's and you can't use negative Y's. So now let's look at the graph of this. And to do that, I'm actually going to use Desmos again just to give us a little bit more practice with that. Okay, so here's my graph. And I've got all these plotted here. Now let's try to interpret each of them. First off, let's start out with our X has to be greater than or equal to 0. If I zoom out here, that simply means that our X values must be positive, which means we're over here to the right of our Y axis. Y also has to be greater than or equal to 0. So if I zoom out, that tells me that my X is greater than 0 and my Y is greater than 0. That intersects up here. So what I can actually do is I can just scroll down here and I can just say, you know what, I've got to be in the first quadrant. So as long as you remember I'm in the first quadrant, that'll keep things okay. Y is less than or equal to 20. I know Y equals 20 is a horizontal line. And look here where I'm at now. So Y has to be between, if I zoom in, here's the x-axis, so Y has to be between 0 and 20. So I've got to be somewhere in this region right here. I also have to be greater than 0 on my x, so I'm somewhere in this over this shaded in region here. And then I have my ultimate parameter I've got to face is I've got to be above this line. So I've got to be somewhere in here is where these four things overlap. So sometimes it's hard to see that. So it's somewhere in this region. So let me change my parameters here so this graph looks a little bit better. There we go. I've changed it up a little bit, and you can see that this region right here, again, your Y values have to be between 0 and 20. Your X values have to be positive, which that really doesn't affect it, and you have to be above or greater than this line. So you have to be somewhere in this region. And we go back and look, we're again just using, we're trying to find some points that satisfy this so that he has the correct postage. And since it's or equal to, you can be on this line. So any point on this line will work as well. So he could do like 5 of each of them would work, because 5 of each would be between 0 and 20 on the Y, greater than 0 on the X. So we can look at 5 and 5 maybe. We could look at points like up here. This would be like the point 6 and 6 of the X's and 7 of the Y's, 8 of the Y's. We could actually use any of them, or just 6 of the X's would work. Six of the X's, and and 0 of the y's. So let's write those down. So we could use 5 of each. We could use 6 x's and 0 y's, and you can see, you can check those parameters. Would it be $1.60? Well, 28 of these would be $1.40. 20 of these, that's $1.40, and 20, that's $1.60. So that checks out. Is your y value less than 20? Yes, it is. Is my x value and y values both greater than 0? Yes, they are. Check 6, 0. 28 x's, that would be 168 plus 0 y's would be obviously 0. Would that give you the $1.60 or greater? Yes, it would. Is your y value greater than or less than 20? Yes, it is. Is it greater than or equal to 0? Yes, it is. Is my x value greater than or equal to 0? So any of those or either one of these values would work.